I was working on OpenCL testing framework for Piglet, and that was my evoc project for the last 3 months. So something about the background. As I've said, it's an evoc project. We decided to use Piglet because it's already being used for OpenGL testing, and the framework can be used for the one I wrote for test-driven development on regression finding. The main goals of the framework were basically to test OpenCL implementation compliance. I was trying to test all OpenCL versions as much as I could, and one of the main goals was, of course, easy writing of tests, so the developer can write tests quickly. So basically, with Piglet, we automatically get parallel execution of tests. Tests can be grouped, and the test results can be easily displayed. Even for the end user, it's easy to run tests. Well, relatively easy. He just runs a command and it tests everything. All the tests should run, when you execute them, should run on all available platforms and devices on the computer they're running on, if the OpenCL implementation allows that. For example, if it has, I think, an interactive device loader or something like that. And but I left an option that tests can be defined that they are specific to some platform or device. Well, I try to share as much common code as possible between tests. So as you will see later, I've added different types of tests. Basically, you include different header and you get different functionality when writing tests. And of course, writing a lot of functions, helper functions, like function that executes some set of API functions that you don't want to repeat in every test. So how is the test written? Well, it consists of 2 parts. You have a configuration part and the test code. In the configuration part, you set some parameters, as I will show later. And that parameters creates an environment for your test. It can already build a program or something like that, so you get a built program or kernel on which you can execute your test. So, as I was saying, different test types were created. One for testing API function calls, one for testing program execution and program building, and custom test types that don't really fit in those 2. For example, if you would like to just try the whole, from the beginning to the end to build the program and write all of that. So why different test types? Because you can share more common code in, for example, program types between each test and the API type. So, as I said, write only the parts you're testing. So, for example, is it okay? This is how custom type looks. You include your header, and you make ignore these 2 lines. I will tell about it later, and make a configuration section. Here you can put a name if to run tests per platform or per device. Basically, if you put run per device true, this function gets executed per each device. And you can also set other parameters. So this is just basically it executes your test function per device or per platform, or you can filter it on which platform you want it to execute it. Basically, if you know that some platform has some functionality that isn't defined in OpenGL spec, but you would like to test it. And this is the test part where you write your function. So this is the custom type that can be used for all of the tests. And this is, for example, an API type. So in API type, you can define on which versions of the OpenCL you are testing. So when you run Piglet to run all of your tests, if you're testing for version 1.1, 1.2, you can pass it as an argument. It just skips the tests that aren't in that version. So you can here have you can create context or program source that gets then passed in the environment variable to the test. And it's pretty much the same with the program test types, just that you have different options. So the other main part, which I worked most of the time on this Evoc project, was a program tester, a binary to test OpenCLC programs. I designed it like this, that you could create that configuration in a comment in a CL file. So you don't need any coding in C or something. You just create a CL file that, when it's passed to this binary, it tests itself. And in this configuration, you can specify inputs to the kernels and specify what output to expect. And this way, we can have multiple tests on the same program. So, for example, this is a CL file. Here you see we have two kernels that basically add or subtract two numbers. And this is a configuration that this test runs. It has a special command, similar arguments than the program test. You can define a global size, local size, if you know OpenCL. Or if you expect test to fail or not. If you expect build to fail, you can also test that. And now you can have different tests on the same source. You can create buffers with currently supports all the buffer types but half type, because you can't. It's not easy to test half pipe on the platform in C. So basically, you can you put in the input and check the output of the kernel execution. You can also set the tolerance, how much the output can vary. So, and also, you can have a special file that contains only the configuration. So you can have a source for the kernel and multiple files that build this source differently. You can test also that different building on the same source. Well, the current status, as I've tested, the Clover platform in Gallium on Evergreen hardware, I think it was Llano APU. As you can see, it passed 32 tests out of 70 total. 30 were API function calls, and the other were program tests testing scalar arithmetics, vector arithmetics, and size of operator, and stuff like that. And as you can see, Intel's implementation of OpenCL and AMD's works. Kernel tests were successful, but most of the API tests failed because of some edged cases. For example, when you create a buffer with arguments that you don't want to fill it with data, if you pass a non-null pointer, it should return an error. But it doesn't. It creates it successfully, and that is marked as an error in testing because it's not by the spec. So current users are mainly guys from Radeon that are also working on Clore. Please fix me if anybody else is using this. And I hope that more developers will use this, so we can have OpenCL and OpenGL testing inside Piglit. Well, for the future plans, the short-term goal is to write a lot of tests. Basically, not all the API is tested, just 30 functions. A lot of tests could be written for kernel tests. A good thing would be to have a CL info binary, something similar to GLX info, so you could see what extensions and similar your hardware supports, and adding support for testing half-type in C. In the long term, it would be good to see OpenGL and OpenCL tests together, like sharing buffers or similar. And as Kronos last week put out the SPIR, Standard Portable Intermediate Representation, which is a binary representation of OpenCL programs. It would be good to have that too. Okay, I was speaking a little bit quick. Yeah, do you have any questions about this?
Right. First, thanks for the good work you've been doing in Piglit.
Thank you.
It all looks really good. It's good to see it arrive. And also, I saw you had test results for Intel OpenCL.
Yeah.
I'm assuming you ran Piglit on the Windows OpenCL driver to obtain those results?
No, on Linux.
On Linux?
Yeah.
Excuse my ignorance. I know very little about OpenCL. Where is it from?
Okay.
Is that coming from Intel itself? From a
the
department we're unaware of?
Intel's web page. I downloaded the OpenCL.
Oh, wow.
Yeah.
Send me a link, please.
I will.
Oh, it runs on the CPU. Okay,
Yeah, it runs on the
okay.
CPU.
Okay.
Yes.
Okay, I thought
I forgot to mention
that makes sense.
that I wasn't successful running AMD implementation on the graphics card. I ran it on the CPU, as you can see. Yeah.
Okay,
Yeah.
that makes a lot of sense.
So OpenCL you can compute on CPU and on GPU on any device. Yeah.
Okay. I believe that Windows is shipping an actual OpenCL driver for recent chipsets, maybe starting Ivy Bridge. So I'm interested in, you could also run Piglit against that.
Windows?
On Windows.
We could try.
Of course, you'd have to update the Ivy Bridge. Yeah.
Okay.
So I missed it. Did you mention your
Oh yeah, I forgot. I would like to thank Tom Stellard. Yes, he was my mentor and he helped really a lot, and it was good working with him. Yeah.
Hey, Egbert. He actually may have already answered the question, but for the 14 and 15 functions that failed for the Intel and AMD, did you file bug reports and let them know that this?
No, I'm planning to. Yes,
Okay.
I was testing recently this week and previous. Well, I've seen this before, but I wanted to make sure on other implementations if it's not something wrong in the tests or
Okay.
haven't tested it correctly. I will report. Yeah.
And did you get your code all checked into the main repo? We don't want to lose the work that you did all summer.
Yeah. It's all, the code is already merged in Piglet. Eric merged it on Tuesday, on Wednesday, I think. Okay, thank you for listening. Oh.
No, not a question. Just one announcement. Kuro actually did CL info for his state tracker work, and he's just open sourcing it live now. So.
That's one thing less to do. Great, thank you. Okay, any more?
Anyone else?
Then thank you for listening.
Okay, thank you very much. This.